Hello everybody. In this video lecture, we will continue covering ecosystems and we will talk about nutrient cycles. And as always, I'm gonna use PowerPoint to help me with this topic. So this is PowerPoint that I will use, nutrient cycles. Okay. So I'm picking up my pointer. Previous lecture, we talked about ecosystems, and ecosystems require two major components to sustain a life, right? And those components are energy and nutrients. And energy flows through ecosystem, and eventually it's converted, some of this energy is converted into chemical energy, and some of this energy leaving ecosystem mostly in the form of heat, right? But we need constant input of energy from the sun. And another component that is needed for ecosystems is nutrients. Nutrients cycle. And we mentioned the major cycles, nutrient cycles in previous lecture, and today we will cover some of those cycles. We're gonna start with water cycle or hydrological cycle. Out of 97.5% of water that is stored on Earth, out of all the water that is stored on Earth, 97.5% is salt water. Remaining percentage is ice. So we have only less than 1% of fresh water out of all this water source that we have that is present in lakes and rivers. So on this pie diagram, you can see that most of the water that we have on our planet is salt water. Then we have, out of this, I don't know, whatever is like 2.5%, out of this 2.5%, we have lots of water that's stored in the form of ice, and only less than 1% water that is, immediately available for us, lakes and rivers. So we are in a storage of fresh water, that's for sure. So water cycle need energy. As any cycle, it needs energy to run. And water cycle is driven by sun's energy. Sun warms the ocean and other surfaces of water, then water evaporates, then water condensates and precipitates. So here's some of the processes of water cycle: evaporation and sublimation, condensation, precipitation, and some flow of water. It can be surface flow, it can be runoff, it can be snow melt, stream flow. So we will look very briefly on these processes to better understand water cycle. So water from the land and oceans enters the atmosphere by evaporation, and this is when water evaporates into vapor, or sublimation. Sublimation is evaporation from ice, right? From ice to water vapor. Then condensation, and condensation into clouds, when water from the water vapor condenses back into a liquid form, and then this liquid water falls. It can be in the form of rain or snow. And precipitated water, the one that falls on the surface, may enter freshwater bodies, or it can infiltrate the soil. And when infiltrate the soil, it can join underground water, and then it can run underground to water reservoirs, or it can stay underground for a very long period of time. But the cycle is complete when surface and underground water re-enters the ocean. So here's the diagram, and that's pretty good diagram because it shows you the major processes and reservoirs for water. So whatever we have here in white show us reservoirs. So here we have water in atmosphere, water in ocean, here underground water, including aquifers and lake and rivers. So water is stored in a different reservoir, and then it's just moving between this reservoir, completing this cycle. And this cycle is driven by sun's energy. Every single drop of water that we drink today, this is the same water that dinosaurs were drinking 65 million years ago, right? And even before that. So if you can see over here, we have water precipitating here into ocean, or it can precipitate on the land. All right, and then we also have some water returning into underground water through infiltration, right? And then this water from this reservoir is evaporated back up to the atmosphere, right? It can evaporate from the surface as well. And of course, we have extraction water for agriculture, but then it can again evaporate back up. So that's, you know, simple and at the same time very complex, but definitely absolutely important water cycle. Human activities affect the global water cycle, and those activities include destruction of forest and pumping large amount of groundwater to the surface for irrigation. So here you can see destruction of the forest. This picture was taken in the same area in the Brazilian rainforest in 1975 and same area in 2001. And you can see how area changed. And this is what, like 26 years only, right? You see how we changing the landscape and how we impact and, you know, interact this water cycle. And another type of interaction of water cycle, when we actually pump lots of groundwater for our needs. This is the area in Nevada, Las Vegas, in Nevada, and you can see this is in 73 and in 2000. Here we have lots of vegetation growing, and Nevada is a desert. To grow that much of vegetation, we need lots of water. And you would think, whoa, that's a good stuff, right? Look, if previous one, look over here, if previous one we destroying the forest, well, that should be a good stuff, right? Because we're growing green stuff. It's not that good either, because we have limited amount of water. And if we bring more water in one area, that means that we drastically decrease amount of water available for other regions, right? The water, because we used so much water for this Clark County in Nevada, because it was so much overused, then the water level in Lake Meads, and water comes from that area, then over there, water level dropped drastically, leaving cities and farms downstream pleading for more water. So again, if we increase the amount of water we use in one area, then we deplete another area of water, and it affects the environment, ecosystem, and it affects economy as well, right? So let's go back again, and we'll see that we can either, how we impact water cycle, either we destroying the forest, or we pump large amount of water, and by doing it, we lower the water table, we decrease amount of underground water, and we get this water from the areas that now are suffering. Another cycle we gonna cover very briefly in this lecture is carbon cycle. So carbon is present in all organic molecules, and its role in the structure of macromolecules is of primary importance to living organisms. All life on our planet is carbon-based. So all these organic molecules, carbohydrates, proteins, lipid, DNA, RNA, that are nucleic acid, they are carbon-based molecules. So that's very important to cycle this carbon within our ecosystems. So carbon dioxide gas exits in the atmosphere and is dissolved in water, exists. So where would we find carbon dioxide? In atmosphere, right? And a large amount of carbon dioxide is also dissolved in the water. So now how to convert this carbon dioxide that is inorganic into organic carbon, right? That, you know, we need carbon in our organic molecules. The process of conversion carbon dioxide gas into organic carbon is called photosynthesis. And now when organic molecules are made, how to return this carbon back to the atmosphere. And that process is called respiration or cellular respiration. And respiration cycles organic carbon back into carbon dioxide gas. So that's pretty much two processes that involve in carbon cycle. Where we get energy for carbon cycle, we get it from the light energy, sun energy again. We do have long-term storage of organic carbon. And this has occurred when living organisms are buried deep underground and become fossilized. So the fossil fuels that we use are actually organic matter, right, that did not decay completely. And of course, activities, human activities, return more and more carbon back into carbon cycle. So here's another diagram, the same as with water cycle. We have reservoirs over here, right? And we have processes that allow carbon to move between these reservoirs. So here, carbon dioxide in the atmosphere, carbon dioxide in the ocean, right? And carbon dioxide underground in the fossil fuels such as coal, oil, and natural gas. So here where carbon is stored, right? And here's our photosynthesis that convert this inorganic carbon dioxide into organic molecules. Let's say this grass over here. And then, so that's producers. Then producers are eaten by consumers, primary consumers, secondary consumers, and producers and consumers through the cellular respiration return carbon dioxide back into atmosphere. When living organisms die, they are decomposed, and again, carbon dioxide return back. But so this cycle, you know, worked for millions of years. We have some amount of carbon dioxide going into producers and some going back into atmosphere. Producers, atmosphere. But now we have lots of fossil fuels, lots of cars running over here. That's all release extra carbon dioxide, right? And plus we cut down lots of trees that decrease the photosynthesis rate. So we increase the release of carbon dioxide and we decrease the amount of carbon dioxide converted into organic molecules, right? So that's how we disturb this carbon cycle, right? So, and that's what we call global climate change, right? One of the reasons, not the only reason, but global climate change is related to carbon cycles. And it happened because partially of rising concentration of the atmosphere greenhouse gases. One of them is carbon dioxide. Another greenhouse gases include methane and water vapor. And like your greenhouse, when you grow some plants in a greenhouse, you have that roof, right? This roof is transparent for light, so sunlight can pass through, but the heat energy, right? The heat energy is prevented for leaving this greenhouse, and that's done for purpose. So you can keep this temperature nice, right? And warm, so the plants can grow better. So the same happened with our planet. So we're building this imaginary roof, right? And this roof is made of these greenhouse gases. So now we have this, this covering surrounding our planet that the same as the roof of greenhouse allows sunlight to penetrate, but keeps a lot of radiation close to the surface. And the same as in greenhouse, we see the increase of temperature on the planet as well, right? So those gases, they absorb or reflect heat and contribute to increase in global temperature that is often called greenhouse effect. So you can see over here how heat is trapped by these greenhouse gases and reflected back to the surface instead of escaping into the space. This diagram shows us very well how carbon cycle is affected by human activities. So forget about these purple arrows for a second and imagine we are back in I don't know, 700 years ago, when we didn't have that much of the agriculture and no cars, no factories. Then carbon cycle only include this photosynthesis, respiration, right? And photosynthesis, respiration in the ocean. And it was a perfect balance over here, actually. Or sometimes volcanic eruption release extra carbon dioxide, but it wasn't that often. But now, look, we increase this increase of carbon dioxide in the atmosphere by our activities, and we do nothing to improve the photosynthesis. Actually, we even, go through this deforestation. We cut down trees and forests, so we even decrease the rate of photosynthesis. Right, so overall, the uptake of carbon dioxide by photosynthesis roughly equals to release of carbon dioxide by cellular respiration. So go in, go out, in and out, that kind of equal. However, extensive deforestation has significantly decreased the incorporation of carbon dioxide into organic material. And carbon dioxide is floating into the atmosphere from the burning of fossil fuels and wood. So here looking at our future, and we can see that carbon dioxide concentration, and this is the time, and it stays, very constant for a long period of time, and then you see this drastic increase in a carbon dioxide amount in the atmosphere. The amount of greenhouse gas emitted as a result of action of a single individual is that person carbon footprint. So every one of us has our own carbon footprint. And it depends on how much electricity we're using, how much we drive, do we recycle or not, do we eat local food or we eat food that is exported, right? So how much carbon dioxide every single person release in the atmosphere, right? So here, schematic representation of carbon footprint that including the fuel we use, right? The electricity, gas, are we recycling or not, and so on. So every one of us can reduce our carbon footprints by reducing the use of electricity, driving less, recycling, and eating local foods. And the last cycle that we cover is nitrogen cycle. So yeah, another thing I want to tell you, when we're talking about carbon cycle, very important, right? Carbon cycle cannot exist without producers, so without plants. So animals without plants cannot complete this carbon cycle. So we rely on plants. Without plants, you know, no carbon dioxide, pretty much moving from one reservoir to another. Plants, algae, you know, some photosynthetic bacteria, right? But when we're talking about nitrogen cycle is not possible without bacteria, right? Even plants are not equipped to incorporate nitrogen from the atmosphere. We have bacteria that fix nitrogen into ammonia, and ammonia is used for proteins, nucleic acid, and we call it nitrogen fixation, all right? So the nitrogen that enters living system by nitrogen fixation is eventually converted from organic back to the nitrogen gas, also by bacteria. So nitrogen cycle relies heavily on activity of bacteria. And here are some processes that occurs in a terrestrial system. We have ammonification, and ammonification is conversion of nitrogen into ammonia. We have nitrification, and this is from ammonia, we go to the nitrite and the nitrate, and then denitrification from the nitrate back to nitrogen gas. Right, so that's the processes. Let's look at the diagram. So here's our diagram. Again, we have reservoir in the atmosphere. We have, and in the atmosphere, we have nitrogen gas, inorganic nitrogen. In the soil, we have ammonia and nitrates, or NO3, and we have ammonia and nitrates in water, right? Now, to fix this nitrogen, right, to make this nitrogen available for plant, for animals, and we do need it, because our DNA, right? Remember, DNA has sugar, phosphate, and nitrogenous bases. So DNA, RNA, they require nitrogen, plus proteins. But to use this inorganic nitrogen, over here, what do we need? We need nitrogen fixing bacteria, right? So we go from nitrogen to the ammonia. So nitrogen fixing bacteria incorporate this nitrogen into organic molecules such as ammonia, right? So, and then this ammonia and nitrates, they are available for plants, right? For producers and then for consumers. Now, when consumers, they don't exhale it, right? Because they cannot convert organic back into inorganic form inside their bodies. It stays as proteins and DNA. So only when they die, right, they are decomposed, and they decomposed back into organic molecules. Right, so here you see we do not have a cycle because we didn't get back to atmosphere. We go from atmosphere to the soil, right? Then we have bacteria that converted into organic molecules. So organic molecules moving through these food chains back to organic. So that's our movement so far, here, here, and back here. But we need, for cycle, we need to complete the cycle. We need to release this inorganic nitrogen. So for that reason, we have denitrifying bacteria. So denitrifying, it's back from ammonia and nitrates back to inorganic form. So that's bacteria that are critical for this cycle. Okay, nitrogen pollution. We have a lot of pollution that is related to increased amount of nitrogen and phosphorus. in our ecosystem, and especially in aquatic ecosystem. And one of this pollution is called algae bloom. So if you look over here, this is like a little pond, and you see all this algae and cyanobacteria growing. And this is not because the water is nice and warm and we have a lot of, sunlight. This is because this water is polluted, and this water polluted with probably nitrogen. Because, so much bacteria and algae should never grow. They should deplete the source of food. So food is not available and bacteria would start dying, or algae would start dying. If we have this overgrow, that means they have too much food over here. Where this food came from? Well, most likely this food came from fertilizer that was used by farmers somewhere up the stream. This phenomena is called eutrophication of water. And eutrophication of water is excess nutrients that lead to algae bloom. And when we have lots of algae use oxygen, and this leads to depletion of oxygen, and fish will die, and other animals will suffer. And that's because lots of fertilizer is used, and fertilizer has lots of nitrogen and phosphorus, and now we're feeding these bacteria, and we're pretty much killing many of other living organisms. So, excuse me. So over here, you can see how nitrogen runoff from Midwest farm fields cause this dead zone in the Gulf of Mexico. So what it's shown over here, it's all different rivers and streams that originate from these Midwest farms. So all these farmers use fertilizer. Fertilizer pollute this water in little streams and rivers, and they all kind of flow together into Gulf of Mexico. So as a result, this area, especially in the summertime, is a dead zone. So no fish, no healthy algae, no healthy microorganism and other marine animals in this area. So that's a big problem. It's getting this problem is getting out of hands, really. Nitrogen pollution. Okay, so let's see. This was our last slide, right? So that's it for nitrogen cycles. Thank you for watching, and I hope it was helpful.